Hello, welcome back to the video lecture series for Introduction to the Art of Programming Using Scala. In this video we continue our look at multithreading, and we're moving on from basic multithreading, the stuff that was built into the original version of Java, to look at the Java util concurrent package. This is a library that was added in Java 1.5 to help make it easier to do a lot of the things that are common when multithreading. Because as you've seen, in some ways using synchronize and wait and notify and join and just creating your own threads, fundamentally it's powerful enough to let you do whatever you want to do. However, it's kind of a pain to do it properly. And so they took the things that people were doing a lot and they put them inside of this package. And we're going to have a few videos talking about these. For this particular video, we're going to focus on what are called executors. And so executors are the method in Java util concurrent of starting up threads. So instead of manually starting your own threads, you ask the executors to start things for you. So inside of the Java API, there are actually three packages here, Java util concurrent and two others that are nested inside of it, atomic and locks. We already looked at atomic in a previous video where we saw that the atomic int gave us a way of avoiding race conditions. Java util concurrent itself has quite a few different things in here, and we will look at a number of these over the next few videos. As I said, in this one, I want to focus on the executor. Now, an executor is basically an abstraction for starting a process. Okay, so it's in some ways, it's like a thread in the sense that, or a run method, and that a runnable, and that you tell it that you want it to do something. The difference is, whereas a thread, basically, when you gave it a runnable, it was going to put it off in its own thread. An executor doesn't really tell you where or how it's going to run this thing. It's just going to execute it. And so different executors will be able to do it in different ways. And this, fundamentally gives you, this level of abstraction gives you more power in how you code things. Now, the executor itself is very simple. It only has this one method. And so most of the time you actually use an executor service. So the executor services have quite a few more methods in here. And one of the big ones to note is something called, so you have the ability to submit runnables, but you also have the ability to submit a callable. And so the callable is something that was new, that was added in Java 5. And it deals with the fact that one of the things that you very commonly want to do is have a thread go off and calculate a value for you. And when you do this with a runnable, well, the run method doesn't return anything. It doesn't give you back any information. And so if you wanted to do that, you would have to store, have some place where you store the information, make sure that that information isn't going to have a race condition. There are lots of little challenges to doing this. And it's not that it's really hard. We've done it, but it has just enough little nuances to it that it's very easy to not do it right. And so because it's such a common thing to do, they created a new type called a callable. And unlike a runnable, a callable, so instead of having a method called run, it has a method called call, and it gives you back some value, okay, of a type v. So there's a type parameter v on the callable that it specifies what type it's going to return to you. And so this winds up being very helpful for when you have functions that you want to give you back values. So let's look at how we could create one of these. So this is an interface. All of these methods are abstract, and really you don't want to have to write one of your own. You want to have the libraries produce one of these for you, and indeed there is a class called executors, and the executors class has the ability to make a whole bunch of different thread pools for you, or different executors. The executor service, there's a cached thread pool, there's a fixed thread pool, there's a scheduled thread pool, a single thread executor, and you can create whichever of these fits your needs. Personally, I find the cached thread pool to be the most useful when I use this. Now, it turns out that in Scala, the libraries in Scala have added things so I don't use this as often as I would have if I were writing straight Java code. What a cached thread pool does is it acknowledges the fact that creating new threads is computationally expensive. There's a lot of overhead to creating new threads. So you don't really want to create a thread, have it go for a little while, and then throw it away when it's done. It's better to remember it so that the next time that you need to do something, you can reuse that same thread. And that's exactly what a cached thread pool does. Now maybe you want to have it so that there's only a certain number of threads happening at a given time. So you happen to know how many cores your current machine has, and you really want to fix your process to only using a certain number of threads. Well, that would be where a fixed thread pool comes in. You can tell it how many threads to use, and it will create those threads and it will remember them. And like the cached thread pool, when a thread is done, it doesn't throw it away. It kind of keeps it off to the side and can give it a new task when a task arrives. The difference is, with a cached thread pool, if you submit a task to it and all of the threads are currently busy, it will create a new one, and then it just continues to remember it. With a fixed thread pool, if I tell it to only use 4 threads, and all 4 threads are busy, and I give it a 5th task, it'll block at that point. So that 5th task, well, it doesn't actually block on your call, but that 5th task gets kind of stored off to the side, and it's not going to execute until one of the other tasks is done. I will point out that if you're not careful, part of the reason why I don't use fixed thread pools all the time is because you can actually get to a situation that's basically deadlocked. If you have nested calling where you use the same executor service. Now, the other thing to note about this submit is what it returns to. It returns a future object. And we're going to see there's a different type of future object that is in the Scala libraries. The idea of future objects, either way, is very much the same, because when you submit a task, the calculation isn't done immediately. It can't actually give you back the result value. But you want to have some way of getting to that result value, so it gives you back a future object instead. And that future object has a method called get, which will block. And so once you get the future object, ideally what you do is you let the thread go on and do its own stuff while you do something else, and then when you need the value, you call get. If the thread is already done, then you get the value immediately. In many ways, calling get is basically a thread.join, but it has the added perk that it gives you back the result of the calculation, whatever it was. So let's look at how we could put this into our code. And one of the things that I want to do here is I actually need to create a function that is kind of slow. And just I want to do a very simple example of this. So let's def fib on executor. And what I'm going to do here is I am going to make an executor service and I'm going to make it so that it uses a fixed thread pool. Okay. And if I hit Control-Shift-O, we should import this. I want, yes, executors from Java util concurrent, and I want a new cached thread pool. Let's remind ourselves, I know that these have a shutdown, and in fact the shutdown is significant. If you don't shut down your executor service, it keeps the threads active, which keeps your whole application active. Okay, it's automatically started up when you create it, so to make sure that it does get shut down, I will put a call to that at the end of the method. And then what do I want to do inside of here? Well, as the name implies, I have this fib. I'm going to use just a simple Fibonacci. Fib of n, and I'm going to use a slow Fibonacci. You might remember from a video much earlier in the book where I first showed you multi-threading, I did this same thing. 1 else fib of n minus 1 plus fib of n minus 2. Ideally, you'd have a more significant calculation, something that you want to do that was going to give you back a simple value. And what I want to do here on my fixed thread pool is futures equals for I in 1 to 10. We'll go with something like that. And let me yield. So inside of here, I want to submit a new callable, and the callable type requires a def call, and I'm going to make it so that my callable here returns an int. And in fact, I need to come up here and say that this is a callable of ints. Control-Shift-O. One from the Java libraries. And what I want this to do is, actually, let's do this. Let's go from 30 to 15 by minus 1. It's possible that will jog your memory as to what this does. Fib of I. Actually, I could go from 1 to 10 and just do 31 minus I is what I'm going to call in there. And so this goes through and it submits a task in the form of a callable to this executor service. And this executor service is doing a cache thread pool. In this case, it probably won't use the caching. Probably none of the, we're going to create all the threads so fast, none of them will finish before we hit other ones. I could do something like, let's do a fixed thread pool and say I only want to do 4 threads. And so even though this loop is going up to 10, in fact we can have it go to 15, it's only going to do 4 things at a time, which works well because the computer that I happen to be doing this on only supports 4 simultaneous threads. So then what I want to do is just run through my futures, and for each one I want to print line the get on the future. Okay? And if we run this as a Scala application, whoops, that will do absolutely nothing because my main has nothing inside of it. So I need to call fib on executor, run as a Scala application. Okay, and now down here in the console, you can see that I got a whole bunch of values. They print it out in order here. And they print it out in order because I run through the futures in the order that they were generated. However, odds are very good this was not the order in which they were calculated. Because each thread was able to do its calculation, and we made it so that the largest one was first. To illustrate this, I could let's do it this way. Valret equals print line calc colon plus. Okay, so I'm going to have one print statement by each thread as it finishes, and then there's another one for the gets, and in fact let's put get plus, so that you can see the difference between when they're actually calculated and when they finally when the get actually calls for the values. And those things, thanks to the future, are not closely linked to one another. It's possible that the get won't happen until the value is calculated, but lots of the values hopefully will be calculated before the get actually calls for them. And that way we're actually taking advantage of the threading. In fact, the fact that we are getting the longest calculation up here, I think I need to do an update on my Scala here pretty soon, so that hopefully it can find a version that is not suffering from this slowdown. Really? Okay, there it went, finally. So if we maximize this, you can see how the things calculated and the order that they went in, and that was not necessarily from largest to smallest, though it did wind up calculating the largest one pretty early, and the smallest one wasn't last, but it was fairly close to it. But the order in here is somewhat random because that's actually when the threads managed to finish. Whereas the gets down here, and you'll notice that almost everything finished calculating before the first value was gotten. Okay, so this is a nice illustration of how the threads were working through things. We could definitely, on our example down here where we were counting things up and we were dealing with race conditions, we could have had futures in there so that this was, instead of using a thread and a runnable, we could have sent this off to an executor service, had a future that returned the value, and then just summed those up, summed up the gets from them. It would have been a very similar type of code, but it would have been easier for us to avoid the race conditions because we would have had the futures that give us back the values. So that's a quick look at the executors and the executor services that exist in Java util concurrent. And we'll come back next time and we'll look at some of the data structures that are present inside of this package for you to help you out with your programming.